Clearly, there's a difference in motion of light particles with different time periods that have relationship of different distances per those same time periods. I've outlined arguments about the ether and the changing of ether causing different values of light and distance. If light travels faster in different places, could we then send mass to travel at different speeds to different places? The discovery of space, where there's impedance in some areas and shortcuts and continuity in others, opens science up to the analytical possibility of a wormhole in which objects travel faster in different reference frames, in different ether states, in different areas. There is no scientific experiment that tests different light patterns in different ether states and relies on those results to mold a new speed of light as a constant. Another observation that may not make sense with the current axioms is that the variability of the actual wave. A wave consists of a peak and a trough, different amplitudes and different frequencies of light. Below are common equations for the speed of light. Allow me to gauge in hypotheticals. If you set one variable at a constant invariant and change another variable, for example, setting the frequency of oscillations of, say, an arbitrary wave like a microwave, so there's no variation of frequency throughout the experiment. If you then alter the wavelength of the vibration, by current scientific ideology, you would then by definition be changing the speed of light in which is said to be held in constant. By that same line of thinking, if you were to set the wavelength to remain constant, then change the frequency of waves during the same set time period, you would then be, by definition, again altering the speed of light, which is said by convention to be impossible. Another aspect of light theory that we can explore are the different morphisms of light. All three dimensions of the light wave have the ability to change, creating different kinds of light with different thickness, length, frequency, direction, and scalar quantity of charge. It seems light also changes in the presence of hydration, starting in lightning storms with the conduction of electricity. Light refracts in some interesting ways. As one looks at the bottom of the pool on a sunny day, it seems light consistently is attracted to each other, where one would think that the ripples of the water would detract from light because of their thickness. It seems to do the opposite, which is to make the light brighter on the bottom of the pool. Just like light, the ether has the same ability to morph in the same areas of thickness, length, frequency, direction, and scalar quantity of charge. Ether also behaves differently in the midst of water in the air, which you can see in weather patterns and in figure above, which is a lightning storm. If you are a traveler, you can plainly feel that the air feels different in different places after a long flight. These differences not only have a direct effect on light, but dictate and morph its speed. As light has different speeds, so do the clocks that measure them, mainly clocks that are based off of microwave functionality, with waves acting in different varieties in length in different areas of the ether, registering in different wavelengths and different frequencies. A tertiary point to analyze the speed of light is the actual idea of wavelength that is said with frequency to create the constant of light with a designated peak and trough, which can easily be remitted as nonlinear. Constants are by definition creations of a linear approach and application formatting into one speed of light. For example, the gravitational constant g being a scalar value encompassing the relationship of matter, distance, and gravity, or the continuous compounding constant e, which is coincidentally has at every one of its points on its line a slope of e, or the constant relating to the circle pi with its exact radial symmetry and circumference describing one half of a circle. These constants have irrational values numerically, but in practice are rational tools giving the natural world order. Unlike those constants, c, the speed of light, has a low and high point, a peak and a trough, dictated by the definition of wave theory. over long distances at any point on the nonlinear line has the ability to change in its wave path. By that definition, it is hard to justify a wave as a constant, especially for long wavelengths and large amplitudes. Variation is the enemy of constantality. The peak and the trough on a light wave differs, and in this regard enters light in the arena of non-constantality. In several of Einstein's field equations, most notably the one above, there is a reference to the speed of light being raised to the fourth power. I believe Einstein did this in reference to standard calculations to incorporate all three spatial dimensions and one of time. It is the product of a square, which makes calculations of area in terms of a square, length times width, easier to calculate. To raise the constant c to the fourth power violates the cosmic speed limit of light dictated by conventional scientific thinking. In the equation above that Hendrik Lorentz derived and Einstein used quite often, the denominator is used to mitigate the numerator in case it was greater than 1 and hence over the speed of light. However, the denominator temporarily breaks the cosmic speed limit and has in its nomenclature c squared. If it were me, instead of violating the cosmic speed limit, but knowing that one would need 4 spatial dimensions represented in a grand unifying theory equation, in order to incorporate those dimensions in the equations, I would need to raise the outward expression of the universe that creates space to the fourth power. It is the most logical to incorporate an outward moving universe that may or may not exist into the lambda symbol, which is satisfaction of a symbol used to create space and time. By setting the two constants lambda and g as antithesis ratios of each other as pairs that we can call binary constants. Representation and unification of gravity lambda concept into a unification of 3 spatial dimensions and 1 of time. The lambda concept's 4th dimension of time could be associated and unified to an electromagnetism concept that works specifically with the relationship of light and time. Light, I believe, c should not be raised to any exponent preserving the cosmic speed limit. Any resulting exponential form of c could not be identified in experiment. The lambda symbol, of course, being the cosmological constant, thereby advantageously shows the expansion of the universe of all 3 dimensions and 1 dimension of time by lambda to the 4th power. This formula can be used in common Big Bang cosmology as well as steady state theory and numerous other theories denoting expansion. According to the second law of thermodynamics, which states that the longer time progresses, the more the system degrades to a higher degree of entropy. This describes some systems, but in planetary and human evolution, I believe the opposite to be true. It seems like the longer the length of time, the more the universe and humanity progresses to a path of order and intelligence. The pursuit to identify and order different species of light hopefully will also progress with time. Having a constant speed of light, although not an accurate description of reality, allows for mathematics and physics problems to be a degree less rigorous and easier to understand and calculate. The formation and construct of a light constant gives humans understanding and comfort. Like other constants, they have a sense of order and principle in an ever, sometimes irrational, entropic world. Opening the concept of different speeds of light up to a classification at first would seem to have a higher degree of irrationality, but doing so allows us to possibly derive a new order and create different categories of different light in exotic forms. To change our time value for the age of the universe based on new calculations of the speed of light is an important ethos in our culture to better understand the universe we live in. Understanding the different varieties of light will allow us to better ask and answer these unknowing questions like how long have we been here? How many light years is the age of the universe? How long will our species last? Are there other species near us? to ignite a deeper pursuit of discovering the unknowing constructs of the phenomena of light with respect to our time.